Welcome, everyone. Kathleen and I are going to introduce ourselves. So welcome to the conference. We're really excited about sharing some of our experiences with you. And these are some of the experiences that we've gained through talking with our customers, through talking with our peers at Planet, and talking through industry trends, etc. Kathleen, I can't actually see the slides.
Oh, okay. Hopefully everyone else can. There we go. We're on.
So I'll do a quick introduction of myself. Leanne Howard, I'm the General Manager of People Excellence and Agility here at Planet. And strangely enough, 5 minutes before the presentation, I had a notification congratulating me on my 20 years at Planet. So definitely something to celebrate and something that I'm really happy to be sharing with everyone here. As well as working for Planet for that long period of time, both Kathleen and myself get really heavily involved in industry events and working towards helping new people coming into our industry and increasing the professionalism. So I'm on the board of the ANZTB. I also on several working groups for ISTQB. I'm in Standards Australia, and I've done some work with the TMMI Foundation on their working groups, as well as presenting at amazing conferences like this. So we have a wealth of knowledge, and we're really excited about sharing that with you. Kathleen, would you like to introduce yourself?
Absolutely. Welcome, everyone. Great to have you listening in on the session. So I'm Kathleen Ramos. I work as the Practice Director for Quality Engineering and Assurance at Planet. I've worked at Planet for 9.5 years now, so 10 years in December. Looking forward to meeting the milestone. Outside of that, I've worked in international standards with ISO and Standards Australia for the last, 17 or 18 years. I worked on the 29119 software testing standard. I've worked on standards for the IEEE, and I'm working on a data migration testing standard at the moment and a quality engineering framework standard. I also work part-time as a professor of practice at La Trobe University, teaching software testing and measurement to the next generation of software testers. And that's through a partnership between Planet and La Trobe. So yeah, all the ideas that we've developed in this presentation really came through from our work with Planet, but also all of our work that we do with ISTQB and ISO and whatnot.
So what we're going to cover in our agenda today is we're going to share with you some of the insights that we see working with a variety of customers, looking at some of their key challenges in the quality and testing space. We're also going to walk through the Q model with you. I'm not going to do a spoiler there. I'm just going to say we're going to talk through the Q model. We also want to share some of our insights into the next generation of quality engineering, how we see the future evolving, and the huge opportunities that they're now creating in our industry. And then we'll just reflect with some key takeaways for our presentation.
Fantastic. So starting with those key challenges in quality and testing, and this is based on both observations we've seen in the marketplace, but also on a survey that we've run last year around the world. So what's happening in the marketplace? Why are we talking about quality engineering and Q model? Where does this come from? Really, we see customer expectations increasing. If we have a look at the way customers or the public viewed quality and testing and the need for quality, 20 years ago when we started our careers in quality, people's expectations on what a good quality system looked like were very different back then. And, you were talking still the age of green screen applications and, probably Visual Basic, VB6 was one of the languages of the day. And, people just didn't have the expectations on performance, security, usability, accessibility, compatibility as they do now. Adding to that is the increasing complexity and integration in the systems, especially heavily integrated systems online systems that are interconnected with all containing a wealth of knowledge and information, some of which you don't want your public to see and some of which you do. But at the same time, organizations are driving for faster delivery, more frequent deployments to production, but with the added bonus of needing to lower the costs. We want more for less. Of course, AI being a great disruptor to the industry, and that's from a positive and a negative perspective as well. I mean, AI, certainly Gen AI, brings great opportunities to optimize the life cycle, especially as we're seeing more and more AI embedded in test management tools, automation tools, and new tools coming on the market that really accelerate the delivery of testing and testing services. At the same time, the challenge of how are we going to test AI systems? How are we going to test AI-driven systems that don't necessarily have that binary pass or fail outcome? It's more towards more of a performance test style of testing where you've got to sample the input domain multiple times, numerous times, potentially hundreds or thousands of times, and to then look at behavior over time with observations on whether the system is behaving within the ballpark of what you feel is adequate or acceptable, rather than that simple, run a test once and see if it passes or fails. So really, more than ever, we see the need for quality and testing practices needing to evolve, now more than ever. However, some of the challenges that our industry face really haven't changed across the last 20 years. These are some of the findings of the Planet Global Quality Index from 2024. We're running the index at the moment for anyone who would like to contribute to the index. It should be available either via LinkedIn or on our website. But we asked, the companies that we surveyed, what are your organization's greatest challenges in quality? And in fact, requirements being unclear, undocumented, or incorrect was one of the most popular responses. And also unclear stakeholder expectations standing out as well. The need to increase speed without sacrificing quality. Automation still being too challenging for almost a third of the companies we surveyed. And of course, a range of other challenges, including testing being too costly or too slow, poor quality work from development. Some of these challenges have been there for a long time. So Leanne and I, it would have been a couple of years ago now, probably 3 years ago now, we're sitting down and discussing these challenges and saying, well, what is it about the life cycle that could be causing some of these challenges? Now, if we picture any typical life cycle, whether you are running a waterfall life cycle that's more traditional, if you're running a sort of continuous life cycle, a more agile life cycle, either way, testing is usually happening after we've done discovery and written requirements, often after the design is in place. And even if you're agile, often the testers won't get engaged until sprint naught. By that time, there's a very large backlog forming. Probably an architect has already designed the system and the solution from a high level, and their product has probably already been decided upon. When the testers come in and we say, well, hang on a minute, the requirements are full of holes, we should have tested those. And the design was full of holes and the architecture is full of holes. We should have tested that too. And of course, even once the system gets to production, when we're deploying it to production and operating in production, we should have tested there as well. We should test continuously. And of course, we should continually improve and optimize our process. Now, the sheer fact that testing comes after development in the life cycle really gives a lot of people outside of testing the impression that testers should come after the requirements are written and at least after the architecture is designed. Now, Dan Ashby attended a conference back in 2016 and he saw a DevOps presentation where they sort of put up the DevOps infinity loop and they said, well, you know what, if you're doing DevOps really well, you don't even need testing. We can just chop the testing phase out altogether. Now, in our opinion, if you drop the testing phase altogether, it kind of makes it look like testing isn't needed at all to some people. You still need testing present in your life cycle. So Leanne and I were sitting down and discussing this conundrum, and I said, well, the problem is testing is there, sitting after development. What you need is a life cycle that has testing and quality continuously throughout the life cycle. It's not that you want to drop testing altogether. It's just testing should not be seen as a passing phase. It's not something that comes and goes from the life cycle. It is something that should happen continuously across the entire end-to-end life cycle. So at Planet, we've been developing Q model as a continuous testing process that embeds testing and quality assurance practices throughout every stage of the life cycle. Over to you, Leanne.
Thanks, Taff. Yeah, it was a really, really interesting conversation. And part of that conversation was driven by the fact that quality is now something that needs to be owned by the whole team. So whilst we might say that there is testers in each of the parts of the life cycle, it doesn't necessarily mean that testers need to do all of that work. We need to work as more quality assistants to help the rest of the team be thinking of quality first, changing their mindset so that whenever we do something, we are thinking about quality first and foremost. We all know the cost of quality model, where exponentially the cost of fixing or doing rework exponentially increases the further you get through the life cycle. So let's stop that. Let's start thinking about quality right at the beginning. So we've put some ideas up on our Q model about what things from a quality and a testing point of view the whole team should be considering when they are working through their activities together and embedding quality into that life cycle. So we should be building the right product at the right time, at the right cost, with the right level of quality. And obviously, the right level of quality is subjective and needs to be driven by your context, what you're delivering, your risk considerations, what your customer base is, and feedback from your customers. So we'll leave this slide up for a couple of minutes. For those of you that are watching the recording, please pause and have a good read of these ideas. I'm just going to pick on a couple of these to go through because we have a lot more of interesting things to share with you, and we only have a very small time to share them. So in discovery, as an example, we need to be looking at what is the customer experience, and we need to be designing that in at that discovery phase. So we need to look at a quality plan and strategy. And quality here is really important. We're not just talking about a test plan or a test strategy. We're talking about that whole aspects and activities that make up quality. As I said, risk assessment, we need to make sure that we are doing a quality risk assessment and we are understanding what our customers judge to be quality, not what the testers, not what the developers, not what the BAs judge, but what the customers and their end customers are providing as the quality attributes. We need to make sure the requirements are reviewed through a whole raft of different review techniques. But we need to, again, ensure that everyone has the same understanding of what those requirements are. So there's no ambiguities. There's no list of 1,000 different questions about the requirements. We adopt things like the power of three. So the people that are working on the requirements all get together, talk to each other at the same time, and come out with the same understanding. We need to make sure that contracts are reviewed and in place to help us optimize that quality. And very importantly, we need to make sure that we take those baseline metrics. And that's one point that's often forgotten about. And then when we come to the improve part of the cycle, we don't actually know how we've improved because we didn't actually start with a baseline. So we could have probably put 20 other bullet points here, but we tried to capture the most important ones. And obviously you need to apply that to your context. And what I would say is when you are looking at applying the quality model or a quality model, you look at your context and decide as a team what areas are you going to focus on and what activities you're going to focus on. And maybe choose 2 or 3 to work on at any one time and improve those and then start on the next ones. I would also give a little tip that it's important because sometimes I see as people do their improvements with whatever method they're using, their task board or a sheet of improvements or a model like this, once they've improved in an area, they kind of cross it off and forget about it. But it's very important that once you've improved in an area, that you continue with those improvements, but looking at the next thing in the line. So is there one in particular, Kathleen, that you'd like to pick through?
Yeah, I think the thing I'd like to call out broadly is that the whole goal of Q model and to us the whole goal of quality engineering is taking that whole team approach to quality. If we leave quality just to the testers, you're going to feel quite disempowered, brought into the life cycle too late to really influence quality. The concept is taking that whole team approach. And, you know, Dr. Aman Feigenbaum, back in something like the 50s in his book on total quality control, said quality is everyone's job. That's been known for a long time, that quality needs to be everyone's responsibility. And through Q model, we're trying to help people understand that, you know, it takes a whole team approach to build quality and evaluate quality as early as possible. What are the BAs going to do to assure quality? What are the architects going to do to assure quality? What are the developers going to do? What are the testers going to do? What can support and operations do to assure quality? And where does the business need to get engaged to decide which quality risks they can accept and which product quality risks they can't accept? It takes that whole team approach to really decide on the right balance of investment in quality and testing practices across the life cycle. And your quality engineering plan and strategy should really, you know, document and capture that whole team approach to quality. You know, forget your separate test plan for, you know, for the testing that the testers are doing, and then the developers are off doing something on their own, and there's no comparison across the test cycles or test levels that are occurring. You want that whole team approach with a collaboration across everyone across the life cycle. So that's Q model. That's where we're going. And I think also what is critical is identifying the minimum quality engineering requirements for your company and your team. So there's a whole host of improvements you could make. There's a whole host of practices you could adopt. You have to pick the ones that really matter the most to your customer and that are going to give you and your company the most benefit.
Yeah, great. So what else have we got to share with them?
Yeah, so moving into what's the next step though, beyond Q model, what's coming next? Really, what we see or what we believe at Planet is that we need a next gen quality engineering manifesto, something that doesn't just take companies into the current state of what we can achieve in QE, but something that really pushes organizations to achieve even more than they thought they were capable of. So at Planet, we're working with our customers on helping them understand how they can transition, not just from testing to quality assurance or quality engineering, but really how to adopt next gen QE practices. And we use this as a guideline or a template to start from with our customers in identifying a quality engineering policy and an organizational quality engineering strategy that really takes them to that next step. So, you know, we use this because it helps customers really quickly understand that testing is seen typically as quite reactive. It tends to happen after development, whereas quality engineering is a bit about being proactive and building a system that, you know, where quality is built into the system, not just that it's evaluated later in the life cycle or after development is complete, or even just after each code component is written. If we view testing, you know, often you'll have those silos between developers doing the unit testing and the testers doing everything else. We want the whole team approach to quality in our next gen approach to QE. instead of just having automated regression testing where we write a manual test and then automate it, really what we want to move to is an automate first approach where we're automating straight from requirements, straight from design, in collaboration with developers, alongside the code being written, with continuous integration, continuous testing, enabling continuous deployment, and with self-healing built into our automation algorithms. And so, also, instead of just doing test process improvement, let's do delivery lifecycle optimization. Let's look at that whole life cycle from a quality perspective, not just from a testing perspective, and ask ourselves, what can we do as a whole team, BAs, developers, testers, architects, support operations? What can the whole team do to help build quality in sooner and evaluate quality sooner to get that product out the door faster? So at Planet, this is, yeah.
Sorry, Kathleen,
no,
that's
go,
really
go.
where the maximum benefits is not just optimizing a very small part of your life cycle by all working together and optimizing your whole life cycle. So you get huge returns on investment if you can all work together as a team.
Absolutely. And I think it also empowers the testers to feel a little more equal to everyone else on the team and have a little more of a say. Now, what else is coming to our industry in terms of next gen QE? Right now, in a lot of organizations, we still have quite human driven processes, which is very normal, very usual, very typical. Where from a testing perspective, we might design a test model that models the requirements. These are requirements coming in. We might design a test model that reflects those requirements. And it could be a use case flow of event diagrams, could be a state transition diagram, some sort of workflow diagram, or it could be a description of the requirements in a way that makes them more testable. We then hop in and, of course, we design and execute tests, ideally in parallel to the code being written, and then we're evaluating and reporting the outcomes. And we're going to have some sort of quality gates in there, not necessarily barriers to moving forward. But even if you have a definition of ready and a definition of done, you have a quality gate to check that the right things are happening before the product goes forward or even before testing moves forward. And of course, in a lot of organizations, that's still a human-driven process. In some organizations, it's quite a heavy rate process of the kind of you shall not pass style of quality gating. And that's okay. If you're developing safety critical systems or hardware intensive systems, you probably want that strong quality gate on some of these steps. What would this look like if we had human AI collaboration? We don't like to think necessarily that we're going to hand it all over to AI one day, because that would probably be automated chaos at the end of the day. But I think the whole industry really needs to sit down. Each team and each organization needs to sit down and say, well, what can we hand over to a AI, whether it's Gen AI, whether it's AI built into a tool? Where can we hand over and where do we still need that human collaboration? Maybe there are some parts of the life cycle where we don't need as much human quality gating, and maybe we can use that to accelerate the process. And certainly at Planet, we've been accelerating with our customers to have a look at what kind of cost savings we can achieve. And certainly the cost savings are, exciting and kind of scary and remarkable at the same time. I will say, if developers are accelerating the rate at which they're writing code, and they're able to churn out code really, really quickly, and yet testers are still plodding along with a manual process to write tests and execute tests, we're going to look like a bottleneck, and we don't want that. So we all need to get on board with really looking at how can we adapt and adopt AI and automation to accelerate our process. One really interesting place that we can do that. Oh, sorry, Leanne, did you have one more thing to add to that?
No, just really emphasizing it's about that collaboration. There are certain things that humans do that will never be replaced by a tool, and AI is a tool. So it's working out how we can collaborate together. What humans do best, let humans do. What AI or any other tool, automation or any performance tool, security tool does well, let the tool do that. So I think we're going to hear a lot more about how we collaborate with our tools and certainly with AI coming soon.
Definitely. And tools like Checky.ai, which I believe has changed to Test.ai, tools like that are really exciting as far as human AI collaboration is concerned. Absolutely. I can't wait to see what comes next. But there
Me
are
too.
some things, yeah, definitely, it's exciting. There are some things that we can use to automate some of these manual processes. This is where I start praying to the demo gods to make sure that my demo works. Now, in teaching at university, one of the stock standard tasks we get students to do when they're learning how to write tests is to design a state transition diagram for a given scenario, and then, of course, build a state table off it and write some test cases that do, zero switch or one switch coverage. Stock standard out of the box testing training. But what can we do with AI to accelerate this process? So here's an example that I used at La Trobe in my teaching. Stock standard cruise control system requirement. And, if I was to draw a state transition diagram for this, if I was being really, really pedantically careful, which I usually am when I'm writing sample solutions for students, this might take me 40 minutes to draw the state transition diagram, because I know I'm very much paying attention to detail, thinking really deeply about it, and peer reviewing as I go. What if I gave this to ChatGPT? So all I'm doing is changing this one little bit of my requirement. I'm just going to take the exact same requirement and say, actually, I want ChatGPT to go ahead and generate this in Plant UML. So you can see I've dropped that requirement into ChatGPT, give it a moment, and it'll go ahead and write Plant UML, which is a language that is used to describe, it's a diagramming language, a metadata language. I can then go into draw.io and say, do you know what, just go ahead and build that Plant UML diagram for me. And with any luck, drum roll,
Fingers crossed.
yay, it worked. Sometimes there are errors. So, at a glance, this looks like a pretty good job. I can't see anything drastic missing. All the transitions look to be there. Looks great. It doesn't have the outputs of each transition, but that's okay. Now, interestingly, yesterday when I ran this, it kind of turned the initial transition into a state, gave me a state for off, and in other cases, it's sort of got really creative with adding notes, and occasionally the diagram gets a little messed up, and just occasionally it kind of puts transitions into states, and that's the one with the transitions in the state. So it does some weird and wonderful things occasionally. The cool thing is you can say, do that again with Mermaid. Mermaid is another diagramming language, but the cool thing about Mermaid is it's actually editable directly on the diagram. So I can come in here and say, actually, just go ahead and do the same thing, but drop that into a mermaid diagram. Oops, sorry, let me try that again. Demonstrations just guarantee things are going to go wrong. And voila, there's my diagram. Looks pretty good, looks good to me. And the great thing about Mermaid is I can just go and edit that diagram directly on the page. So even without fancy tools, even just with a really simple Gen AI, a free version of ChatGPT, and you can massively accelerate your test modeling process. From that, you could ask ChatGPT to go ahead and build your state table. You will find some of your diagrams, as I said, get messed up. ChatGPT does not draw state tables very well. You've got to really coax it in the right direction. And then from there, you can generate your test cases. Even that will save you hours of time in test design. We've found ChatGPT is particularly good at finding edge cases and negative tests, but especially junior testers might not think of. We have found it really lifts up junior testers incredibly well, and it will always add value to accelerating the work of more senior testers. So, I'll hand back to you, Leanne, for the summary.
Yeah, I think just before we move on to that, I think the important thing there, which that demonstrated when you went through a number of models, because you used exactly the same input to create the model, is some of the challenges that we as test professionals and quality engineers are facing now when we are actually testing tools and systems that use AI. We don't have now a binary expected result. So that's one of the, disruptors of AI, as well as the benefits of AI. And obviously you can use this, Kathleen demonstrated lovely, the state transition, but you can use it to demonstrate and build a lot of different test models to help you get started. So it's really, really interesting, and, certainly powering through our kind of imagination of where we can take this now. So that is so, so exciting for our industry.
Definitely.
So just to summarize, what are some key takeaways? And hopefully we've walked through some of these with you. So definitely the pressure is on to do more with less. And this is driving innovation, which is amazing. It's great that in an industry that has really stood still for a little while, I would say, we are really now at the forefront of innovation. And I think us as quality engineers and testers are actually leading the way. So I'm really, really excited, and amazing for those people that are just now joining the industry. So exciting. So our software quality lifecycle practices absolutely need to evolve to keep pace with the modern ways of working. So we need to invest in that optimization that Kathleen was talking about, that looking at ways that we can improve, and critically working together as a team to see how we can embed that quality in right from the beginning, and using the tools appropriately where the tools add value, and collaborating with humans where we add value. So the Q model provides an innovative solution for embedding that quality across the whole of the life cycle and reducing waste, which will allow us to get quicker or deliver more exciting features for our customers, and ensure that our customers are coming back to us and your customers, end customers, that they are staying with your brand, because we all know that people hop brands very, very quickly. They only have to have a 30-second bad experience and they'll move to another provider. And finally, AI and smart technologies are really, really going to enable us to uplift towards that next gen quality engineering. So if you have not had the chance to start experimenting with either AI or some of the other smart technologies, I would say make some time this weekend, this evening, this week. You really need to be experimenting and getting those competencies and skills in your toolkit so that you can keep pace with the way the industry is going.
Couldn't agree more, Leanne. Couldn't agree more. Well, thank you so much, everyone, for listening in on our session. Hopefully we'll have some questions coming through. We'll wait and see if any questions pop up on the screen. And you're always welcome to reach out to us. There are our LinkedIn codes on the screen. So you're welcome to reach out to Leanne and I if you ever want to get involved in ISO standards or any area of volunteering that we do. Please do reach out. Okay, we've got a question coming in. You demonstrated the use of ChatGPT to generate state transition diagrams. Yep. Have you used it to generate other types of test models? If yes, what was the outcome? Brilliant question. So definitely, certainly through my teaching at La Trobe and in our work with our customers, we have tested ChatGPT in particular and our own in-house Gen AI tool called Amplify. We have used it to generate a lot of different test models. So, use case flow event diagrams. It is particularly good at flow of event diagrams, particularly good when you can generate them in Mermaid because you can edit them as you go. It'll also generate more traditional use case diagrams, flowcharts, and also it'll even support you in just identifying potential, equivalence partitions and boundary values and even syntax test values that you can use as inputs to your system. Even if you don't necessarily give it the requirements, it can take pretty broad guesses pretty well. And in fact, a year ago, ChatGPT was not particularly good at equivalence partitioning and boundary value analysis, and now it's a lot better. I have to say, it gets it pretty well right a lot of the time. Sometimes it adds in an equivalence partition value to a boundary test, but does a pretty good job. But I will say, state tables, it's not good at unless you coax it. Sometimes with writing the actual test cases, you have to really coax it. You coax it by, of course, giving it the right prompts. And if you have to abandon the prompt altogether and start over. But yeah,
I think
certainly.
The other tip, Kathleen, that we found is if your requirements or the thing that's under test for your organization is something that's in a well-known industry, so such as finance or banking, then the models tend to be better. If you are in an industry, maybe if you're in a startup, in an innovation industry, in an industry that's in its infancy, and the underlying learning is not there for that industry, then it does sometimes struggle to generate those models.
It does. If I don't want my students cheating on the exam, I give them a new technology, and it doesn't cope with new technologies very well. Okay. Have we got any other questions from the audience? Here it comes. Yeah, so you mentioned that, organizations looking to adopt Q models should identify a minimum set of quality engineering techniques to suit their organization. How would you recommend going about that? Absolutely. Excellent question. I would always start with a brainstorm amongst the architects, BAs, developers, testers, support operations, and the business, ideally the business owner or a business representative, to really sit down and say, what are the biggest pain points in our life cycle as it stands, and where do we think we'll get the best return on investment for embedding quality engineering and testing practices across that life cycle? Leanne, did you want to add anything to that?
Yeah, I think I did talk about this when I was talking about the model, is get those baseline metrics. They are a really good input into identifying where you might want to start. So, for example, if you are seeing a lot of defect leakage, so defects that should have been found in the requirements phase, for example, but you're not finding them till UAT, that to me is a big red flag to say, go and have a look at your discovery or design phases and really work together to make sure that those requirements are understood by the whole team. So there are some that you can gather that will be really good indicators on where you should start for your particular organization.
Yeah, I couldn't agree more. Thank you, Leanne. That's a good call. Use metrics as your guide. Absolutely. Defect density, as Leanne said, defect slippage. Yeah, absolutely. Defects per requirement even, and use that to really motivate the investment in the right places. Great. So
I think we might have run out of time. We could carry on talking for the next 3 hours about this. We're really, really excited to have the opportunity to share with you some of our ideas. And as Kathleen said, we are really open to people connecting with us and joining other forums with us where we can talk through your individual needs and situations, or we can talk about just trends that we are seeing and some ideas to help you. So please reach out to us. Keep the questions coming. If there's other questions that we didn't get to answer, because I know we only get to answer 2, and I'm sure there were loads more questions. We have committed to answering individually your questions, and they'll get passed on to us, and we will commit to reply back to you. So thank you, everyone. Enjoy the rest of the conference. I know there's going to be some amazing talks. So please enjoy. For those of you on the video, please take a second watch because we did go through a lot of information. Bye and see you later.
Thanks, everyone. Bye.
software testers. Move beyond theory and master testing with the AI-powered ISTQB add-on practical tester by A4Q program. The ISTQB add-on practical tester by A4Q equips you with the theoretical skills and practical competence to truly excel. Learn how to apply black box testing like a pro. Estimate accurately, write flawless defect reports, and catch issues early. The ISTQB add-on practical tester by A4Q complements your ISTQB certification by turning knowledge into powerful action. Visit our websites and find out more information.